GeopByte.
Welcome to GeopBytes. So, I hope you guys are doing well, and we have come to the third chapter of mathematics, that is chapter 3, Trigonometry. So, trigonometry. So, the word itself gives something which is matrix, which is trigono. Trigonometry basically deals with angles, and waves kind of functions, and these trigonometries are mostly used in they find its applications in electronic circuits, and they are even used in seismology and even music tones, and also in finding the heights and heights of the tides in the ocean, some kind of they have many other applications. So actually this chapter is very simple, but you have to by heart some formulas. So by heart some formulas, but with the proof will be easy to remember the formulas. So in starting with trigonometry, first we need to know what an angle is. In our smaller classes, we would have already learned about angles. So what is an angle? Angle is made by two rays like this. This is my point with a common vertex, that is O. Here my ray is OA and OB. So this is my angle. Angle, if this is the case, then I can write angle AOB or angle BOA. So this is angle. So already we know what an acute angle is, which is less than 90 degree, and what an obtuse angle is, which is greater than 90 degree, and an right angled triangle which is at 90 degree. So for right angled triangle, we have learned the most important theorem, that is Pythagoras theorem. So this is the just recap of what we have learned already in our lower classes. This Pythagoras theorem. So what is an acute angle? Acute angle is less than 90 degree. So this is if this is my 90 degree, so my angle will be subtended less than 90 degree. So this angle will be less than 90 degree. So this is my acute angle. So what is an obtuse angle? Obtuse angle is greater than 90 degree. See, this angle is greater than 90 degree, right? So never forget to name your rays and put the arrow mark. So this is our obtuse angle, which is greater than 90 degree. So this is about angle, and for angle we have a common convention. So if this is my ray AOB, if I put the arrow like this, then it is going which direction? Anti-clockwise direction. Oh. So this is known as positive angle. Okay. So never forget to put the arrow mark for the rays. So with the common vertex O. And what is negative angle? My arrow is like this. That is, if I am turning this pen with an angle from here in this direction, then it is negative, which is in clockwise direction. But here I am turning my pen like this. This is positive and this is negative. So this is the basic of angles. So with this we will try to figure out more and more formulas which is used And you have like in exams you may be having to solve very difficult problems. We'll try to work it out in the session. So in order to understand an angle, okay, now we know what an angle is. Now we need to measure our angle. No, there should be some units to measure our angle. That is, there are two units usually we use. One is degree or another is radian. So we use these two units to measure our angle, like how much degree it is rotated or how many radians my ray is rotated, or so we use these two units, and there is a conversion factor. Conversion factor to this. So before that, I'll ask you something. If this is my line, so what is this angle? Somewhat it is in between 90 degree. This is my 90 degree. Okay, so this is in between 90 degree and 0 degree. No, this is 0 degree and this is 90. So it may be somewhere around 45 degree. Okay, so now tell me, what will be the angle like this if my arrow is pointing? Tell me what can be the angle here? It is in the negative, it's in the positive direction. No? So what would be the angle? It will be positive. If this is in between, this is 90 degree, 90 plus 45. What would be the answer? It will be positive 135 degree. No? Okay, now tell me about this. So how many degree it rotated? This will be 360 degree. This is same as circle. Circle we rotate from here to here. It has how many degree? This is 360 degree. No? So my ray rotated for 360 degree. My angle is in this direction. So it will be plus 360 degree. So what if it is here and my angle is here? Then what would be the degree? This is 90 degree. This will be 45, but it's in the clockwise direction. So it is minus 445 degree. So in this way we can find which angle, like positive or negative angle, it has rotated. So now we'll come to the conversion factor. So degree and radians. So the basic thing what we have to keep in mind is 360 degree is equal to 2 pi or 180 degree is equal to pi. So if we know these at least one, either of the one, this or this, if either of the one is kept in mind, you can convert all angles very easily from pi to from degree to radian and radian to degree. So coming to the degree and radians. So what is degree? 1 degree is equal to 60 minutes and 1 minute equal to 60 seconds. So this we know. So and also now from that 180 degrees is equal to pi radians. Then what will be 1 degree? Cross multiplication. Pi by 180 radians. So this is what I have written here. So if you know the basic cross multiplication, this is same as if 5 apples are costing 60 rupees, then what about 2 apples? How much? This is apples, this is rupees, then how many rupees for 2 apples? It's the same as this is x, is equal to 16 into 2 by 5. So it's the same thing. It's the same thing what we are doing here. So similarly, you can put for one radian. That is 180 degree is equal to pi radian, or 1 radian is equal to 180 degree by pi. So this is what I have written here. So if you know one thing, that is this just one thing, you can convert it from degree to radians. So another important topic which comes under this is about a circle and the theta angle here, if this is the radius, and this is the arc length, that is L is the arc length and theta is the angle rotated, and my r is the radius. Then I can write theta equal to L by r. So this is the relation which is very important, that is theta equal to L by r, whereas L is the arc length, the r is the radius. So if you know these three, like this formula, this conversion formula and this thing, you can solve some problems. And 1 radian is approximately equal to 57 degree 16 minutes, and 1 degree can be written as pi by 180 radians. So this we have solved it. Now we'll write corresponding degree and radians chart. This will, if it's remembered easily, then we can solve the problems very easily. Let it be 30. We usually use 30 degree, 60 degree, 90 degree, 180 degree, 270 degree and 360 degree. Okay. So corresponding radius, we can write it as pi by 6. Why pi by 6? Pi is 180 degree, no? So what about if pi by 6, then it would also be 180 by 6. What is this? It's 30 degree. See? This is how we get pi by 6. What would be this? Pi by 3. What would be this? Pi by 2. This will be pi. What is 270 degree? 180 degree plus 90 degree. No? It is 270 degree. That is, this is my pi plus pi by 2. So pi plus pi by 2 is 3 pi by 2. So I write 3 pi by 2. If 180 degree is equal to pi, then what about 360 degree? It is 2 pi, just 2 times. 180 into 2 is 360. So this will be my 2 pi. So if you guys remember these three, like 1, 2, 3, 6 degrees and the corresponding radian conversion, it will be easy for in the future. Now, so I will give you an example, that is 40 degree and 20 minutes. This is in degree. Now we have to convert it into radians. How you will convert? This is 40 degree, no? So what about 20 minutes? It's 40 degree plus 20 minutes. What is 20 minutes? We know that 1 degree is equal to 60 minutes. What about 20 minutes? It will be how many degrees? Because for conversion, this is in degree and this is in minutes. So we have to convert both into degrees first. Then we have to convert it into radians. Okay. So what would be this? This will be 20 by 60. That will be 1 by 3 degree. Okay. So 40 degree plus 1 by 3. 40 degree into 1 by 3. So what would be it? 4 3s are 120, 121 by 3 degree. And we know the conversion factor here, 1 degree is equal to pi by 180 radians. So what about 121 by 3 degree? It will be 121 by 3 into pi by 180. So this will be 121 pi by 6 3s are 24 2 5 4. So this will be 540 radians. So similarly, you can convert everything into one unit or one unit into another unit. But everything, like first, instead of converting first to radians, we have to first convert these two values into degree. Then only we can convert it into radians. The previous example, we checked how to convert degree into radians, and now we'll learn how to convert radians into degree. So we know that 1 radian is equal to 180 degree by pi. So what would be for 6 radians? It would be 6 into 180 degree by pi. So it's actually very easy if we know either this or this or this. So either of the one we should keep in mind. Before going to the next topic, we'll do one problem for this formula. So this is the question. Find the radius of the circle in which a central angle of 60 degree intercept an arc of length 37.4 centimeter. So what is this? Actually it's a circle. It's a circle and we know it's 60 degree because it's given. So my theta is 60 degree. Now what is my length? It's an intercept of an arc of length. So this is my arc length. So this they have given, which is 37.4 centimeter. They have asked us to find out the radius. So L is equal to 37.4 centimeter. What would be the R? But we know what is the formula? Theta equal to L by R, or R equal to L by theta. What is my L? Centimeter. Well, what is my theta? It's 60 degree. But we have given this. What is it? Pi equal to 22 by 7. So we have to convert 60 degree to radians. What is 60 degree to radians? We know 60 degree is pi by 3. Already we have found it out. So 37 by 0.4 divided by pi by 3, or 37.4 divided by 22 by 7 into 3. So this would be around 35.4, I guess. 4 or 1. So this is how you solve a problem with this formula. This is 35.7. 35.7. So this is an example for using this formula, and we have even used this one. So see, now we are connecting all the things we have already learned.
GeopByte.